Hello and good morning to everyone. So, as today's pattern is recursion. So, this is a very important pattern. If you have to do DSA, then I must say that you must know recursion, right? So, what is recursion? So, basically, I hope you know functions. You know functions. So, basically, those are a set of statements or codes to do a particular task. So recursion is basically a function which call to itself only. So suppose let's assume this box as a function. So what this function do is it again calls itself to do a particular task. So in recursion what we do is we took a big problem and then using recursion we will be divide that problem into smaller similar problems. Okay, so suppose we have to find the sum of 10 numbers, right? So can't we do it like 10 plus sum of 9, right? So see, this bigger problem we have breaked into this smaller problem. Then sum of 9 can be 9 plus sum of 8, this way. So we are breaking this bigger problem into several similar smaller problems, and with this we move to the end of the problem, or we can say the final solution. So recursion is almost like similar to loops. So basically in loops what we do is we execute same statements again and again, but in recursion same function is executed again and again instead of statements, and with different value of different parameters, right? So two important things that we should keep in mind for recursion, that are first is base case and second is recursive call. So let's say this is a recursive function. So here there is a base case and then there is a recursive case. So what does this base case tells the function? It tells the function where it should stop. So basically base case is a condition where the recursion should stop. So in the case of finding sum of 10 sum of n, so if n is equal to 1, in that case we will be directly return 1. Okay, so that's the base case, that the condition which makes the recursion to stop. Okay, next thing is recursive call. Okay, so when we have to call the function again, that is recursive call. Okay, and if there is no base case in our what you call function, then the function will keep calling again and again to it infinite times, and in that case stack will overflow, and so we must think when to stop. So we must keep these two things in mind: when to stop and where to call the function again. These two questions you should ask to you in every recursive or every what we call every question of recursion. Okay, so next is recursive call. What is recursive call? So it's the function calling itself, that is when to call the function again. Okay, and why is the function calling itself? To reduce the problem into smaller problems. So let me tell you a very important concept. So when a function is called, right, when a function is called, a new stack frame is created that has the function parameters, functions local variables and return addresses. So when a function is called, a stack frame is created for that function which has parameters, local variables and return address, and then that stack frame is stored in a function call stack, right? That stack frame is then pushed on to the top of the call stack, and which function will execute? The function that is present at the top of the stack will execute, right? The rest of the functions will wait for the execution of the top of the stack. So this is a very important concept. You must keep it in mind that whenever a function is called, a stack frame is created for that function that has parameters, local variables, and return addresses. And then this stack frame is pushed on top of the stack of the function call, and the function which is present at the top of the stack gets executed, right? So let me show you this function a. So what it is doing is, first it is printing statement 1, then printing statement 2, and then calling function b, and then again printing statement 3, again is printing statement 4. Now let's see what is b doing. So basically the function b is printing from 0 to 5, right? B is printing from 0 to 5, and after printing it, it is returning 1, right? So if you see here, so first in our stack we have function a called, then it will print statement 1, print statement 2. Now function b is called. So instead of printing statement 3 and statement 4, we get b at the top of the stack. So now b will be printed, sorry, b will be executed. So what b will do is, b will print from 0 to 5 and then return 1. Okay, wait. So now b has executed. So our output is statement 1, statement 2, 0 to 4, and then b will return 1. So here now this statement will execute. So it will print 1 after printing 0 to 4. It will print 1, and once b done its execution, it will be removed from the stack. So now a is again on the top, and in the stack frame it is also stored that up to which point a has executed. So up to this point a has executed, so it will start executing from here. So b returns 1, so it will print 1 and then print statement 3 and then statement 4. So this is how functions are executed using the stack, right? So let's see another example. So suppose we have to find factorial of a number n, and it is given that you can't use a loop. So first question is, what is factorial? So factorial of a number n is product of that number up to n, right? So factorial of n is 1 2 3 4 up to n, product of all numbers up to n. And factorial of 0 is 1. So keep this also in mind, factorial of 0 is 1. It is not 0, it is 1, right? So if you'll see the function for it, so function is factorial of int, we are passing integer n whose factorial we want. So the base condition, this is the base condition, yeah, base case we can say, that if either n is equal to 0 or n is equal to 1, in that case we will be returning 1. Else what we'll do is, else we will return n into factorial of n minus 1. So if you see, let's take an example of factorial of 5. 5 is equal to 5 into 4 into 3 into 2 into 1. So can't we write factorial of 5 as 5 into this value? This value is factorial of what? 4, right? Factorial of 4. So that is what we are doing, is we are taking n and finding factorial of n minus 1, that is factorial of 4 for 5. Okay, now let's see this how this function calling will be happened. So we have called the function factorial of 5. So what factorial of 5 function will do, it will check the base condition. So base condition is not satisfied, so it will call factorial of 4. Factorial of 4 will call factorial of 3. Factorial of 3 will call factorial of 2. Factorial of 2 will call factorial of 1. Now if you have seen, the base condition was if n is equal to 0, yeah, n is equal to 1. So here n is equal to 1 means base condition has satisfied. In that case we have to return 1. So we have returned 1. Okay. Now at 2, what was the statement? N into factorial of n minus 1. So what is n here? 2. And what is factorial of n minus 1? 1. So 2 into 1, it will return 2 here. It will return 2. So here n into factorial of n minus 1, it will return 6. It will return, and then the 6 will go to here. Then 6 will return n into factorial of n minus 1. That is 4 into 6 and 24. And at the end 5 will return 24 into 5. That is I think 120. So this way the execution of the functions take place. So initially see, factorial of 5 is pushed into the pushed into the this stack, then 4 is pushed, then 3 is pushed, then 2 is pushed, then at the end 1 is pushed, and 1 gets executed completely, then it is removed, then 2 will start executing again, then 3 will start executing again once 2 is completed. As the answer of this factorial of 3 depends on the answer of factorial of 2, so it will wait for the completion of this function. I hope you are getting this. And one more thing, whenever you do recursion questions, make sure to draw diagrams like this will help you in visualizing properly. Okay, so what are the type of recursion? So there are two types of recursion. One is linear recursion. So the above example, that is 5 is calling 4 is calling 3 is calling 2 is calling 1. So if you'll see it a line, so it's a linear recursion. The other is multiple recursion. So we will see both these types also in detail. So first one is linear recursion. So as we have explained above only, like this 5 4 wala thing. And then multiple recursion, so more than one function call inside a function. Okay, so a function is there, suppose, so it will call it multiple times with different parameters, that is multiple recursion. So let's take an example, finding nth element of a Fibonacci series. I hope you know what is a Fibonacci series. So this is the formula of Fibonacci series, that is Fibonacci of nth element is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2, where n is greater than equal to 2. So this is a condition. So if we'll see a Fibonacci series, so initially 1 and 1, that is Fibonacci of 0 is equal to 1 and Fibonacci of 1 is equal to 1, that is the condition. So Fibonacci of 2 is equal to 2 minus 1, Fibonacci of 1 plus Fibonacci of 0. So these values we have already. So 1 plus 1 we get 2. 2 plus 1 we get 3. 3 plus 2 we get 5. 5 3 8. 8 5 13. 13 8 21. So this way this is the Fibonacci series. So if I ask you not to use loop and you have to use recursion for this, then what will you be your code, right? So this will be your code. So first you are passing a number n. So if n is less than or equal to 1, n is less than or equal to 1 means n is 0 or 1. In that case we return 1 only, right? And else what we'll do is we'll call Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is what we have taken in the formula. So we have directly calling those only, as Fibonacci of n is equal to sum of these. So we are calling those directly. So see how small the code is. But if you'll see the execution of this, it's little bit complex. So let's take an example of Fibonacci of 7, right? So we have called Fibonacci of 7. So initially this is Fibonacci of 7. So it will call Fibonacci of 6 and Fibonacci of 5, and then take sum of these two. But 6 will call 5 and 4, and here 5 will call 3 and 4, right? 3 will call 2 and 3 will call 2 and 1, right? And then this 2, let's say it will call 1 and 0. So here if you see the condition has this is the base condition, so they will be returning 1 and 1. So 1 and 1 is 2, so it will return 2. Here also base condition, so it will return 1, and then 2 plus 1, so it will return 3. So Fibonacci of 3 is 3. Then this 4 has called 3 and 2. Here calling are there, but I haven't shown you because already we know that Fibonacci of 3 is 3, so it will return 3, and Fibonacci of 2 is 2, it will return 2. So 3 plus 2 5, then 5 plus 3 is 8, right? And similarly we get our answer from this side also. Here also I haven't shown the further callings, though they exist there, but I haven't shown. So Fibonacci of 4 is 5, and Fibonacci of 5 is 8, then 8 plus 5 13, that is Fibonacci of 6. So for Fibonacci of 7, Fibonacci of 6 is giving us 13, and Fibonacci of 5 is giving us 8. So Fibonacci of 7 is sum of these two, that is 13 plus 8 21. So I hope you get this function calling. And one more thing, if you have noticed here, same calls are done again and again. So if you want to optimize it, you can also store the answers. So once the answer is pre-computed, so suppose Fibonacci of 4 was pre-computed here, then there is no need to compute it again. You can directly use that solution, right? So some common mistakes that we have to avoid are: first is base case is important, so no, don't forget the base case, else your recursive call goes calling itself infinite times, and then our stack will be filled, and then it will give us some TLE or something. Or maybe we have base case, but the condition is such that it never reached, right? Or we are modifying the wrong variables in the recursive call, or expecting recursive to run in order. Run in order means suppose A is function, so here statement 1, statement 2, and B is called, and then statement 3, statement 4. So we expect it to run statement 1, statement 2, statement this, and then this. Instead of waiting for this, we thought that it will run these statements, but that is not the case. It will wait for the completion of B, then only it will execute this these statements. And then forgetting recursion uses stack, because recursion uses stacks for storing, right? Then the next important concept is backtracking. So it is a very important concept. So what is backtracking? So we have seen recursion, right? So recursion plus undo. Undo what? So suppose while going from one function call to another function call, suppose we have a variable. So we have changed the variable value. We are increasing the variable value every time we move from one function call to another. So when coming back, we should reduce that value. So undoing that value while coming back, undoing that value while coming back, that is backtracking. That is changing the value. So backtracking is used when we are try all possibilities and then undo the choice if it does not work. So suppose we have increased value of A, then go to this case, increase its value. Now we come back, then if we don't get answer or we get answer, we will be reducing that value that we have changed while going. Means when we are moving ahead in recursion, so suppose we have changed, make some changes, so in backtracking we will undo those changes, right? So let's see an example. So suppose we are given an array and uh, we have to return all the subsets that has the sum k. Okay, so if we'll see the code for this, I'll tell you where this backtracking comes in this code. So index sum k and the vector. So this is the base condition. These two are the base conditions. Either we get the sum as k, then we'll push the path in the answer and return back here, or the array size, or the array has the index has gone out of bound, or sum is greater than k, then also we have to return. If these two base conditions are not satisfied, then what we do is we will check it at each element. So suppose we have 2 3 5 6, so we will check whether we will be taking this element or not taking this element. So suppose if we are taking this element, then we are pushing this in a vector path, and then we'll call with index. We'll increase the index to next one and increase our current sum with nums of index, right? And calling the function again. So if you have seen, if we have picked the element, then we have updated the vector path as we have pushed the nums of index. Now if we have to simulate the case of not pick, then we should remove that element before going to that case. So this is what we are doing. Path dot pop back, that is removing the element that we have pushed into the path to simulate the pick case that we have taken the element. So this is backtracking. We have made some change in the path, and now we are undoing that change because we don't need that change in the future calling. Now not pick, in case of not pick, we just increase the index, and then our sum will remain the same only. So if you'll see here, let's this 1 2 3, our array is 1 2 3, and we want the sum as 3. So first case for 1, initially our sum is 0. So if we'll pick 1, then sum is equal to 1, and in path we have pushed 1. Then we move to the next case, that is 2. For 2 also, uh, case is pick, so sum is now 3, and this is 2 1 and 2. Now we call for 3, but here sum is 3, so we'll store the answer and then come back again. Now for 2, what we'll do is we'll do not pick case. Not pick case means we won't be taking 2, so we have to return remove this, right? Then our sum is 1, and then 1 plus 3, picking 3, 1 plus 3 is 4, right? So it's greater than k, so we won't be taking that, so we return to the initial case, that is sum is 0. Now not picking one case, so not picking one case, we have to remove 1 from the path, right? So this way backtracking works, that is undoing the change that we have done while going further in the recursion. So if you'll, I'll show you the whole tree structure, or we can say the function calling of this. Wait, yaar. Okay, so our array is 1 2 and 3, and our k is also 3. So initially we have called the function with index is equal to 0, sum is equal to 0, k is 3, and array. So suppose this is a calling. So now first case is pick the first element, pick 1. Okay, so if we'll pick 1, then we call uh, index, increase index by 1. Our sum is increase from 0 to 1. K and array will remain the same only, right? Then after picking 1, we went to 2. So in 2, the first case is pick 2. So if we'll pick 2, we have index increase the index with 2, increase our sum by 3, and k is equal to 3, and array. So now here sum is equal to k. So we'll store this answer, this path. So what this path will give us, 1 and 2. So we get 1, our answer is 1 and 2. We store this path and then we return back. We won't move ahead. So now what is the second case here? Not pick 2. If we won't pick 2, then our we shifted the index by 1. Uh, we increase the we won't increase the sum, so our sum earlier was 1, so it will still 1. So now we have moved to index number 2. So here also we will take two cases, pick 3 and not pick 3. So if we'll pick 3, our sum will become 4. So the second condition, that is sum is greater than k, has failed, so it won't move ahead, it just return back. Then the case of not pick 3. Okay, so not pick 3, but our index is equal to n, like we have reached uh, index number 3 and we don't have an index equal to 3. So the second case condition again satisfies, so we return back. So now here also we won't get answer, so we return from here to here, then we return from here to here. Now here we have simulated the pick 1 case, in that we get answer this. And now not pick of 1, in not pick of 1 our sum is still 0 only. Now here we take two cases, pick of 2 and not pick of 2. So if we'll pick 2, our sum is 2, and then wait, I'll shift you. So our sum has become from 0 to 2, and then we move to the second index. Now here we'll simulate the pick of 3 case and not pick of 3 case also, but I won't be showing both the cases, right? So this way we will be doing all, we'll trying all the possible, all we'll trying all possible cases, we are trying all possible cases, right? And we store the answer as per our conditions. So I hope you are getting it. And also here, while coming back, if we are picking 2, we are pushing 2 into the vector. So while coming back from that 2, that function call, we will remove that 2, right? So this is backtracking. Now some common recursion problems that you can practice to understand it more clearly. Sorry, wait, guys. So some common recursion problems. So for beginner, finding factorial, finding sum of digits of a number. So finding sum of digits of a number, let's say this is number, reverse a number. So suppose you are given 453 and you have to reverse it 354. So that you can also do with recursion. Printing numbers from 1 to n. So these are good problems to understand how recursion works. Next, like for intermediate, you can practice this Fibonacci one, palindrome checking whether a array या string is palindrome or not, yeah, finding the power, like finding x की power n, or binary search also we can do with recursion. Then we have advanced like questions, permutations, finding all the permutations of like, have you seen that question, you are given this what we call these symbols and you have to find all the permutations, you have to find all the subsets. And queen problem, this is a very good problem. So you are given a grid and you have to place n queens in the grid such that no two queens cut each other, right? Or maze path or DFS, like these are very good problems, you can practice this. And I hope I am able to explain you recursion and backtracking, like the theory concept properly. So now try to implement this concept with questions and learn. So keep coding, keep growing. Thank you. If you like the solution, please make sure to like, share, and subscribe the channel. Thank you. That's it.